Another college board study question for AP Physics 2. A battery of EMF, the voltage is given, and neglectable internal resistance, 3 identical bulbs and the switch S that is initially open are connected in the circuit shown on the right. The bulbs each have resistance R. Students make predictions about what happens to the brightness of the bulbs after the switch is closed. Student makes the following prediction about bulb 1. Bulb 1 will decrease the brightness when the switch is closed. Do you agree or disagree with the student's prediction about bulb 1? Qualitatively explain your reasoning. Try to solve the questions before I solve them for you. You can see all the questions right now on the screen. You can pause, try to solve the whole problem, and then you can watch the rest of the video. This way you learn even better. I redrew for you 2 circuits. So in the first circuit, before the switch is closed, you have the total resistance is 2R. So the current through the circuit is equal to the voltage divided by the total resistance. Then the power on each bulb is going to be equal to I squared R. So in our case, it is I squared, which is EMF squared over 4R squared times the resistance, like let's say this resistance, which is R. And if I cancel one of the R's, I don't have much, oh well, I can scroll up, I will rewrite it. So if I cancel one of the R's, I have the power in this circuit as EMF squared over 4R. So this is the brightness of each bulb on the circuit before the switch was closed. After the switch was closed, these 2 resistors become R over 2. It's 1 over 1 over the result flip over. So I have 1 over R, one of them R, 1 over R, the other one is R. And that gives me 2 over R. And you have 1 over 1 over. Result needs to be flipped over. So that gives you R over 2. So this one is R over 2 and this one is R. So the total resistance in the second circuit is 3R over 2. So here is your bulb 1 and here is your bulb 1. So that is 1. And to calculate the power, there is the current right now. So let's calculate the current in the circuit with the new resistance. So the current is equal to EMF divided by the total resistance, which is 3R over 2. So 2 goes on the top. And the power on R1 on the first resistor is equal to the current squared, I squared R, so I'm going to use again the same formula, I squared, so that is 4 EMF squared over 9R squared times the resistance. So one of the resistors cancels and I have 4 over 9, and then I have EMF squared over R. So here you see that 4 over 9 is 0.4444, so that is 0.444, and 1/4, because that is 1/4, is 0.25. So it looks like the brightness of resistor 1 increased. And how else you can say that the brightness will increase? Right here you had R, so the total resistance between this point and this point used to be R, and the total resistance after they added another resistor is R over 2. So because your resistance drops right here, the total resistance of the circuit decreased. Before it used to be 2R, now it's 3R over 2, the total resistance. So that means the current will increase because you will divide EMF divided by resistance. So the current is increased. And when the current is increased and squared, you get brighter bulb for bulb 1. For the next part, they say before the switch is closed, the power expanded by the bulb 1 is P1. Derive an expression for the power, the new one, expanded by the bulb 1 after the switch is closed in terms of P1. So our P1 was equal to, before the switch was closed, is EMF squared over R to R squared. It's the current, which is the voltage divided by the total resistance, but they need I squared, times, let me rewrite it this way, maybe it's going to be easier. So the current in the circuit is EMF over 2R, so that's the current for the first circuit before this bulb is connected, and times the resistance, right? It's I squared times R. So that gives you EMF squared over 4R. So that is your P1. For the second circuit, P2, you had EMF over 3R over 2. So it gives me this much. So that was the current, the voltage divided by the total resistance squared, times the resistance. So that gave me 4/9 E squared over R. So I see right here is 4P1 is equal to EMF squared over 4R. So P2 is equal to 4/9. But I see that this part is equal to 4P1. So I'm going to write 4P1 instead of that. And my final answer is 16P1 over 9. So that is brightness of P1 in terms of P1 before the second bulb was connected. So the second one is when the bulb is connected, and the first one when the bulb was not connected. And for the last part here in A, they ask you how does the result in your derivation in part A1 relate to your explanation in part A2, where you said that the brightness of the second bulb is going to go higher. So here you can say that P1 was equal to 1/4 EMF over 4R squared, and now it is equal to 16/9. Actually, let's do this way. It's 4/9, right? It's this formula. It's 4/9 EMF over R and EMF over R. So you can say that this number is 0.25, as I mentioned in before. So this number is 0.25 and this number is 0.44. So that shows you that this one is brighter compared to the first one. Or you could say that P1 is equal to 1/4 EMF, this one is squared, over 4R, and P2 is equal to 16/9 P1, because this number is greater than 1, then that means P2 is greater than P1. For B, they say a student makes the following prediction about bulb 2. Bulb 2 will decrease in brightness after the switch is closed. Do you agree or disagree? Prediction of bulb 2. Explain your reasoning. Justify your explanation with calculation. So again, if the second bulb is not connected, then the brightness of these two bulbs is the same, and we said the power is equal to the current, which is EMF over 2R squared times the resistance on either that bulb or this bulb. But now they're asking about the second one. So the power on the second bulb is the same as on the first bulb before the bulb is connected, the third one. EMF squared over 4R. After the other bulb is connected, we have the current for the second bulb, or for the second circuit. So the current for the second circuit is going to be equal EMF over the total resistance is 3R over 2. So your current when it reaches, so that was the current, and when it reaches, so the current is going to leave this way, and when it reaches the split, it's going to split evenly because both resistors are the same. So when we connect the second resistor, so the second resistor is now connected, then the current is going to split the same. So when I split the current the same, I'm going to get 1/2 of each of the number that I have. So the current in the top is going to be 2 EMF divided by 3R and divided by 2, which gives me EMF over 3R. And the second bulb, the one that they're asking you about, is also going to have EMF over 3R. Now, if I want to calculate the power on the second bulb, and that was the first one, or the second one and the first one, they're the same before the third one was connected. So the power on the second one is the current, which is EMF over 3R, squared times the resistance of the second bulb. So I'm looking at the brightness of this bulb. Its resistance is R. So I get EMF squared over 9R. And the question says, the student makes the following prediction about bulb 2 will decrease in brightness after the switch is closed. So if I compare these two, I see that before I had a 4 in the denominator and now I have a 9 in the denominator. So I see that the brightness of bulb 2 goes down. And that concludes that the justify your explanation with calculations, and you say you agree because the current in when the switch is closed, the current is going to split in two and the current is going to drop, and because the current is dropped, the power is equal to I squared R. The power of the second bulb is going to go down. And for the last part, for C, they say while the switch is open, bulb 3 is replaced with an uncharged capacitor. The switch is then closed. How does the brightness of bulb 1 compare to the brightness of bulb 2 immediately after the switch is closed? Justify your answer. So when the current is flowing through the first resistor, as soon as the switch is closed, the current through resistor or the bulb 1 is higher than it's going to be through 2, because when the current is reaching this node, because now instead of the bulb I have a capacitor right there, and the current has no resistance in that circuit on the top on the third one. So all the current is going to go through the capacitor and nothing will go through the bulb. So the bulb is not going to have any electricity or any current floating through it until the capacitor is charged. And when the capacitor is charged, the current is going to stop going that way and will continue going this way, the same as before the capacitor was connected. So immediately after the switch is closed, you have the brightness of resistor of the bulb, the P1, is high because the total resistance of the circuit is, at first you had 2R as the resistance of the circuit, right? Because you had two bulbs connected. And then when you connect the capacitor, you disconnect this bulb. So your resistance drops. It's not 2R, it is now R. And because that one drops, the current increases because the current is equal to the EMF divided by the resistance of the circuit, which is R. And the current is only flowing this way, but not through the other bulb. Then your brightness of the first circuit, of the first bulb, increases. And the other one is the second one. This one is off. How does the brightness for the second part of the bulb 1 compare to the brightness of the bulb 2 long time after the switch is closed? So after the switch is closed for a while, so if I have the switch is closed for a while, it's the same as having the switch open. So if the capacitor is there, it's the same as disconnecting this circuit. Because the capacitor is charged, it has exactly the same charges on this plate as the battery and the same as this one, the negative charges. So the current will not go this way, the current will go only to this way. So it's the same as when the capacitor on the switch was closed, back to the same circuit. And at this point, the brightness of the first bulb is the same as the second one because they share the same current, I squared times R, and they have the same resistance, gives you the same power. So for the second part, they say, how does the brightness of the bulb 1 compare to the brightness of the bulb 2 long time after the switch is closed? And you would say here the same. And then in the first one, you would say, how does the brightness of the bulb 1 compared to the brightness 2? You say this one is bright, it's on, and brightness of the second one is equal to 0 because it is off. Or you say the brightness of the first one is larger than the second one.